So what we're going to do is with our compass, we're going to put our point on one end, pencil on the other. Because we want every side in our equilateral triangle to be the same as this. Point on one end, pencil on the other. And all we're going to do is we're going to swoop it up. Our goal is to eventually find like our vertex that's up on top of this equilateral triangle. So just take your compass and swoop it up. And then we're going to reverse where our point and our pencil were. So now put your point over on the other side. And pencil on the other side. And swoop it up. And where those two arcs intersect, that's just our third vertex of the triangle. So with your straight edge, connect from the end point of the original line segment up to that vertex, and that creates our equilateral triangle. Now, something that will come into play tomorrow. What is the degree value of each of the angles in an equilateral triangle? All the angles in the triangle. 180. Well, with equilaterals, everything should be the same, so what's each individual angle? Okay, so that idea that equilateral is a 60-degree angle will come into play for what we're going to do tomorrow. All right, we go down to the second one. We're going to do an equilateral triangle construction, but we want all the sides to be exactly that. So to do that, start with your straight edge. Just make a line segment that's bigger than that. And then what we're going to do is we're going to set our compass to the length of the segment that was given. Put a point on one end of that segment. And on the other. And then we're going to bring our compass down to the line segment we drew, put your point on one end point, and make it up. Now this length, this is just going to be the base of our equilateral triangle. And we'll now, using that length, just do what we did above. So you can try to keep your compass right where it is, swoop it up. And then we'll reverse it, we'll put our point on the, where the arc in our line segment. And scoop that up. And then connect endpoints to that intersection. And that gives us our equilateral triangle at the length of the What's the measure of each of the angles in that triangle? Questions on those first two? All right, go over to the next page. We're now going to construct a square. So the key features of the square that we'll use to construct it, it's got right angles, all the sides are congruent. So we'll start out, just make a random line segment that's a little bit longer probably than the one that we take the equilateral triangle. And just put a point on there that's somewhere, it doesn't have to be right in the middle, but just don't make it at the very end. We're going to want some room on either side. And our first goal is we're going to make a right angle at that point. And we're going to use one of our basic constructions that we did on the first half here. We're going to create a perpendicular line that's through a point on the line. So we'll start by putting our point on that point and make any arc that hits the line twice. So where those two intersections are, we're going to think of those as the endpoints of a line segment. And we're going to bisect that line segment. So put your point at one of the intersections, and then we've got to open our compass more than halfway to the other intersection. And we're just going to swoop it up and swoop it down. And then we're going to reverse it. So put your point on the other intersection, keeping your compass the same. And we'll again swoop it up and swoop it down. And we'll just connect where they cross with a line segment and extend that line segment a little ways. And that's going to give us our right angle. We're guaranteed that's the right angle. So now what we're going to use is the fact that a square has side lengths that are all the same. So we just need to decide how long we want the square to be. So what we're going to do is put our point at the spot where the right angle is, and just make an arc of any size on our original line segment. And what that'll do is that'll create our second vertex of the square. And we just want to make sure all sides are that same length. So keep your point of the compass right where it is, and we'll mark off that same length on our perpendicular segment that we had created. We'll put a point there. We now have 3 of our vertices of the square. So we still just need that top right vertex. So keeping your compass exactly the same, I'm going to move my point to this bottom right vertex. I'll make an arc up above it. And then keeping my compass exactly the same, I'll put my point on that top left vertex and make an arc. And wherever those cross, that's our 4th vertex of the square. And with our straight edge, just connect the other 2. So that gives us a figure with 4 right angles and 4 congruent sides. So we got this. Any questions? All righty, let's skip 4 for a second. We'll come back to it. Let's go to 5. 5 is going to be very similar to what we just did, except there'll be one less step at the end. So an isosceles right triangle has a right angle and 2 congruent sides. So essentially what we're going to do is we're going to do this same construction. But once we get to 3 vertices, rather than finding the 4th vertex, we'll just connect those 2 vertices, and that'll guarantee that it's an isosceles right. Isosceles right. So we're going to do the same steps, except connect the ones to make the diagonal at the end. So we're going to let you try these steps on your own for a few minutes, and then I'll jump in and start doing them up here if you're getting stuck. I'm going to start it up here in case you're stuck. So just pick a point on a line segment. We're going to create a perpendicular line that goes through that point. So put your point on that point. and make an arc that hits the line twice. And we'll do the perpendicular bisector of that. Put your point on one of the intersections, open your compass more than halfway to the other point, swoop it up and swoop it down. And then reverse it, put your point on the other intersection. Swoop it up and swoop it down. Connect those intersections to make your right angle. And then from that green point there, just mark off the same distance on the original line segment and also on the perpendicular line. It doesn't matter how long it needs to be. We just need to make sure they're the same so that it's an isosceles triangle. So I marked off there. I'll mark off up here. And then I'll just connect those 2 points I just created. And that makes an isosceles right triangle because we created it with a right angle, and we just made sure that those two sides. Okay, so your legs of the right triangle might be bigger than mine, might be smaller than mine, doesn't matter, just as long as they're the same. And then we got a right angle here. Any questions on it? All right, let's go back to 4 now. So we're going to construct an isosceles triangle with that base and these legs. The legs are the congruent ones in the isosceles triangle. It's going to be somewhat similar to the equilateral triangle construction, but we're going to change the length of the compass. So we'll start out, just do a random line segment, and make sure it's longer than what our base is. So nothing bigger than that. And now we're going to set our compass to the length of the base. And then we're going to move down and put your point on one endpoint of your line segment and just make it up. So that now guarantees our base of the triangle that we want. Next, we're going to go up and set our compass to the length of the leg. And we're going to essentially do what we did for the equilateral triangle, but just do it with our compass now at a different length. We're going to put our point back on one of the endpoints. And we need to get that intersection up on top. So make an arc going up. And then we're going to reverse our compass. So put your point at the other end of the base that we created. And make an arc going up. And where they cross, you'll just connect those to the endpoints of our base. And that creates an isosceles triangle with the exact dimensions that they want. The base we wanted and the width. Let's go over to 6. We have 2 more we're going to do. We're going to do an altitude. From vertex A, what does altitude imply from proof? Perpendicular line. So now there's a perpendicular line that goes through A. So first we're going to put our point of the compass on A and make any arc that intersects the opposite side. Doesn't matter how big, as long as it hits side B. And now we're going to do just like we did at the start of the square. We're going to use these intersections as endpoints. And we'll just do the perpendicular bisector of the line segment that's at those intersections. So put your point on one intersection, make sure you open more than halfway. It doesn't matter how much, just more than half of the way. And we'll scoop it up and scoop it down. Put your point on the other intersection. Keep the compass the same, scoop it up and scoop it down. And then you'll connect your intersections, but make sure you extend it so it passes through A if you need to. And so we just created a right angle right there. That's an altitude, and altitude is going through the vertex and forms a right angle with the opposite. And we'll look at one last one over on the next page. We want to construct a median. We want to make sure we do it from vertex B. So that means we want to go from B over the side AC. What does median imply from groups? We didn't see it come because it's in our original part. Median implies a midpoint. So we want to find the midpoint of the other side. We can do that by just doing our perpendicular bisector construction. So just put your points at either A or C and open it more than half the distance to the other point. So I'm going to start on point A. And I'm just going to make sure that I am open more than half the distance to C. And then I'll scoop it in both directions. And then we'll reverse it, put our point on C and keep the compass the same. We'll keep it in both directions. And then connect those intersections with your straight edge. And where that perpendicular line crosses AC, that's the midpoint. But we're not done yet. We have one more step. We need to connect B to that midpoint, and then that represents our so of those, because there's always one construction on the region, each of these has been on there at some point, essentially. That's why we're doing these. So a lot of them kind of go a little bit further than just the basic 6 construction. So for homework, you've got 4 of these. So it's on the next 2 pages, page 5 and 6. Probably have time to get that done. Right now, you can do homework. Probably around help you out again.